In this video, I will talk about Buffon's needle problem. So first, here's the setup and the question. We have a needle of length 1 unit and a lined piece of paper with lines 2 units apart. We'll assume the needle is just a line. We drop the needle on the floor and we want to know the probability that the needle will cross one of the lines in the piece of paper. For example, this one crosses a line and this one does too, and these two don't. We want to know the probability that this will happen. So first we'll need to define some variables in order to solve the problem, which are the following. D is the distance from the middle point of the needle to the closest line, and theta is the acute angle formed with respect to a horizontal line parallel to the lines on the paper. So the range of the variables will be, for example, D will be between 0 if the middle point of the needle is here, to 1 if it's here, around here. Because the distance can be negative, well, and the maximum distance from the closest line to the needle midpoint is 1, halfway. And theta will range from 0 if it's like this, the needle is completely horizontal, to 90 degrees if the needle is completely vertical, because we're talking about the acute angle. So when will the needle cross the line? Well, the needle can at most be a distance of 1 from the closest line, as we said. So we draw a circle such that the center is at the center of the needle. Then we will know from the definition of the trig functions, which is this, right here, namely the sine is this one, so the sine is this one, that the blue line is equal to sine of theta over 2, since the hypotenuse equals 1/2, which is half of the needle. This one is sine of theta, just sine of theta, because the hypotenuse here equals 1. And here the hypotenuse equals 1/2, so it's sine of theta over 2. Then the needle will cross or touch a line if the blue line is greater than or equal, respectively, to D, the distance to the closest line. So the needle crosses the line when D is less than sine of theta over 2. So we want D, the distance to the closest line, to be less than the blue line, so that the needle will cross or touch a line. So, to calculate the probability that D is less than sine of theta over 2, we can consider the function sine of theta over 2 ranging from 0 to 1. There will be a curve which represents the first 1/4 of the sine wave. You can see how it's going to continue. And under that curve will be represented all the cases where the needle crosses a line, while the whole sample space will have an area of 1 times pi over 2. So pi over 2, because this is base times height. So we need to calculate the area under the curve by doing an integral and divide it by pi over 2 to find the probability. So we have pi over 2, the integral from 0 to pi over 2 of 1/2 sine of theta d theta equals a. So 1/2 the integral from 0 to pi over 2 of sine of theta d theta equals 1/2 times minus cosine of theta, that's the integral part, minus 0 evaluated at pi over 2 and 0. At pi over 2 we have 1/2 minus 0.5, which equals 1. And at 0 we have, at 0 this is 1/2 minus 1, which equals 1/2. 1, which equals minus 1/2, sorry. And then 1 minus 1/2 equals 1/2. So that's our final answer for the area under this curve. So the area of the whole rectangle, as we said, is the base times the height. So we have 1 times pi over 2 equals pi over 2. This means that the probability is 1 over 2 over pi over 2. And then the 2's cancel, and we have a probability of 1 over pi. So not only did we find the solution to Buffon's needle problem, but we also found a way of calculating pi, which is the following. So to estimate pi, we can use a very large amount of needles and count the ones who crossed the line and count the ones who didn't. Then divide the ones that crossed the line by the total number of needles and take the inverse of that number. This will work since the probability that a needle will cross a line is 1 over pi. And well, it will be an estimate because we will not use an infinite number of needles, obviously. So that's it for this video. I hope you enjoyed and understood, and please leave a comment if you'd like to see a specific topic in the next video. Thanks for watching.